Okay, this is ECN 325 Lab 7, and we are building the circuit for PNP transistor to do the measurement for the transistor characteristics. We prepare everything, so we have the transistor 2N3906, which is here, and we have 250 collector resistor, but since I don't have the 250, I will have to use two resistors in series. One of them 150 ohm, which is this one, and the other is 100 ohm. So the sum of the series connection will be 250. Okay, so let's start first by putting the transistor. The transistor, if you look at the flat surface, it has the legs here, or the terminals of the transistor, defined from left to right, where this is the left one is the emitter, the center one is the base, the one to the right is a collector. The board, as you know, it's connected in series, so this whole lines, number 25 for example, this whole line is connected, while the top part here is connected horizontally. So this is vertical lines, while this one is horizontal lines. So basically, the best way I love to do with this one is to put the transistor somewhere here. Okay, so right now I have the collector leg connected to line number 30, while the base, which is the middle one, connected to 31, and the emitter with the far one here connect to line 32. If you look at the diagram on the picture here, the emitter connected to the ground. You have many ways to do it, but what I prefer to do is to take a wire from here to one of these lines and to consider it to be the ground for the whole circuit. And for this reason, I will use a very small wire. Okay, so I brought a wire. It's a tiny wire ready for these things here. Let's take the smaller one. And what I will do is to connect it to the line at the top here. So this wire here, and I want to connect it here. So by doing this, now all of these lines are connected to the emitter. And basically what I will do, I will connect the ground of the circuit to this line. So this is my ground right now. I can do the same thing with the collector, but let's finish with the base. So the base has 200 kilo ohm. Unfortunately, I don't have the 200 kilo ohm, so I have to do the same trick as we did with the collector resistors. So I have 100 kilo ohm. So this is 100 and another 100, so this is 200 kilo ohm, and what I am going to do is to connect them in series with the base. So the base again is the middle line. So here is a line, this is going to the base, and another point somewhere away a little bit to give me space for the circuit. So let's have to make it secure enough. Okay, so this is 100 kilo ohm, and then let's do another one. I usually try to bend the resistor outside so I can have good control on where it was going. So this is the second one, and I will go all the way here. It doesn't matter where actually I go. Okay, so right now I have 100 kilo ohm and another 100 kilo ohm. They are connected here to the base of the transistor, which we call it series connection. So the last terminal here, which will be line 44, the vertical line 44, this is the line where I will connect the voltage source number 1, V1, and I will show you how we do this. Let's connect the collector resistance. So first of all, I have also two resistors. So line 30 is the collector, as we said, so let's give us some space. So I will connect to the line at the bottom here, and here is the second one. Then the second resistor will be in series, so it connects to the same line where the first resistor ends, and it will go somewhere. We don't care actually where it will go right now, but I have some space. So right now, the end part of the collector resistor is at line 15. So line 15 is where I should connect my power supply number 2. Okay, so right now, this is my whole circuit. It is almost ready, but without any power supply. What we are going to use for the circuit is this device, is analog discovery 2. This is actually work as oscilloscope and power supply and a lot of other things. You already know how this works. This is what we are going to use, and it's color coded, and you can find the color coded online. We are going to use all of these things here. So let's put the circuit back, and let's see what is this question want you to do. In Lab 7, basically in this part he wants you to measure the characteristics of the transistor. He said apply a ramp signal from -5 to 0. So I will have a ramping signal from -5 to 0. And at 1 Hertz, we'll do this one later on the screen. Alright, so basically it is V1. So I need V1 here to be ramping up signal. So this will be the function generator, which is W1 in my case. If I look at the Agilent, my W1 is the yellow, is the function generator, is my yellow wire. So since it doesn't have any connection here, I will add a small wire. I have wires different size here. I will try to keep the wire with the same color coding so we can actually use them. So I will attach here a yellow wire. Okay, and now the function generator, which is W1, this is what connected to the base. So if we look here, this is one resistor, second resistor. So this is my line, which we said is 44. I will go to this point. Now this is my function generator. We need a ground, of course. I will take the ground from the function generator, the black one. This is the ground for the whole circuit. So we said this is the ground for the emitter, because the emitter is connected to the ground. So what I will do, I will put the ground here. Now I actually tell the circuit that I define this whole line as my ground for the circuit. So the ground is defined usually by your power supply. Okay. Right now we have everything. We still need to have, according to this signal, we need V2 to be constant at -5 volt. V2 is what connects to the collector. So for this one, we'll use the positive V, which is here the red color. Alright, so this is the red wire, and this is the signal that will be stable at -5 volt. Alright, and since I need a -5, instead of using the red one, I can use the actual negative value here, which will be the white one in this case. So let's use the white one instead of the red one, because I need negative anyway. I can of course change the value from the actual power supply, but it's always better to do it like this. So you can use the negative V volt, which actually will going here to V2. So this is basically will be connected to line 15. Again, I use the -1 here because this is what the circuit require. Okay, I can do the same thing with the power supply. It is -2. So instead of using the yellow, I can use the negative, but the function generator doesn't matter actually. Alright, so this circuit will run from -5 volts at V2, and it will be ramping up V1 from -5 to 0. Then we need to plot other things. We need to connect other stuff. We need to connect a measurement. And the first graph, basically what he wanted me to plot is the relation between the IC, the current in the collector, and the VEB. Okay, so how I measure this? I don't have in this device anything to measure current. So the best way to do it is to calculate the voltage across the two collector resistance here, and use this value to find the current using a math function, which I will show you in the screen later. So first of all, let's use a channel to collect this one. I will use a channel 2. Doesn't matter what you are going to use. I will use a channel 2 in the scope. So I have to use the 2 positive and 2 negative to measure the voltage across these values. To do this, I will need a blue. So channel 2 is the blue. We have here the blue one. Okay, and I have another light blue, so I need to get another one for the light blue, because you need the 2 channels to measure. So it's 2 positive and 2 negative, and this is the light blue. Alright, and it doesn't matter which direction, because it will give you negative sign anyway. So if I put this here and the other one here in the collector here, now I am measuring the potential difference between across this resistor. Basically, I can actually do something better. I can actually move this resistor closer to the collector like this, and now it is clear that I'm measuring across the two resistors. So this is basically will give me VC, not VC, will give me the voltage across the collector resistor, and I will use the mathematics on the function to be able actually to calculate the current. So this is the current. Now I need the VEB. For this one, I will use the orange channel, which is channel number 1, and try to measure the VEB, which is the voltage between the base and emitter. So I have here, this is the one, I have orange connected to the orange channel. So again, where is the base? The base is the middle line here. It is the middle leg of the transistor. So I can go here at the back and connect it to this point, or connect to any point on the same line. But I need also to have the negative when connected, which is the negative of the channel, so I can get the potential difference. And this is basically should be connected to the emitter. But since the emitter is connected to the ground, I can actually ground it by connecting this here directly. Now this circuit is complete and we're ready to run the function and measure the characteristics of this circuit. Okay, you can see most of the points here, where is the connections going and where is every point is going, and it's better to see it by the line number. Now we come here to the actual waveform, and we are running this circuit. So let's start by putting the things we have. First of all, I have wave generator. I have this is setup. First of all, I'm going to channel 1, right, and it's synchronized. We are going to ramp up, and I'll choose 1 Hertz as the question said. Then we have the amplitude to be 5 volt. So this is the first thing. This will be ramping from, we want it to be ramping from -5, so it looks like here it is -5, ramp up to 0, then we can see the rest of the data. We don't need them because we don't have actually changes here. This is the first thing. Then you go to the power supply. I'm connecting the negative power supply, and the question said the negative power supply need to be at -5, so this number need to go to -5. Okay, and it's ready. Then let's go back here and let's look at the oscilloscope. So for the oscilloscope, this was from previous run I had. So basically I have a channel 1 and channel 2 ready. All what I have to go is to come here. Let's close this data for now, and I will come here at option at the channel, click here and choose custom. So this is math, custom math. And what I will do is to remove this and put channel 2 divided by the actual value of the resistor we have, which is 250 ohm. And I go back down here to the units so I can get everything is correct, and I will choose units. Alright, so now I have the math which will present. Now I don't need to see channel 2 actually, which is the blue line, which is the voltage across the collector resistor. So I don't need this one to be recorded. Okay, I can actually go up here and click on data, and now it shows me channel 1, which will be VBE, and it shows me the amount of the current of IC passing through the resistor. And now let's press on a single, let's make sure first that everything is working. Wave generator is running, power supply is running, and I will press a single run for the scope to collect data. And this is all my data I have here. Let's go really fast through this data. It has weird values a little bit, but we can eliminate the strangest value. So if you look here, usually what you see here, this is usually like this. This is the time. What I did is open the time, and I changed this from default to 512 point. I don't need to get 8,000 data point. You can actually move them to a lower value. Let's test it. See what happened here. It is a little bit lower values, and that's 1 kilohertz to collect more data points. So let's run it again. And this is, by the way, VBE. So as you see, this is the values, and it's going up all the way here. Now let's go and export this data. Click here on export, and it's telling you what you want to export. So basically, I will export comments, I will export headers, all right, and all the labels for this data. He will export only what I see. So now it's exporting channel 1 and math channel, and this is all the data you export with all the values and parameters you have used for this part. So let's click save. Okay, and now this data will be saved. I will just save them on my desktop. Give it any name. I will call it ECN Lab7 measurement 2. Alright, so it's number 2 PNP transistor, and I will save it. It will save as CVS. Here is the data. This is the Excel file data I have. So basically I have channel 1, which is the VCE. I can just come here and rename it. This is the VBE, sorry, is what I meant. So it's actually, we are in EPE, so it's usually we write it VEB. This is the voltage between both of them. And here the value here is actually IC, and it's in amps, by the way. So this is in amp. So let's choose this column and go insert. Scatter data, and this is what you have. So basically it's plotting wrong data. So you see these numbers here shouldn't be like this. So I will go here to select data. All right, and I need only to show the data, so I go to edit, and if you see here the data actually started from column 26. So I'll come here and say, okay, I don't need column 25. Oh, things have changed, sorry. Let's escape it and do it again. So here this will be 26, and this is also started from 26, and it's plotting this data. So this is the data values we have. Okay, so you see that the value is in negativity. All right, so I don't need the negativity of the values here. So basically what I need is I can take the absolute value for this data. So double click here on the x-axis, and I'll do some modifications for these values. So this is will start from 0, right? And if the maximum, this one, no, let's start from negative 0.6, all right, and its maximum will be 0. It looks like there is more data after negative 0.6, so this will be negative 0.8. Right, it looks better. Yeah, that's okay. And this is the data here. So the current is negative and the value here is negative, which we can actually switch by taking the absolute value for all of this to match the actual value. So this is because we take the subtraction, so this means that the channels will connect it in opposite way. Okay, so there is a very easy way to correct this. Actually, just I come here and I say this is the column will equal absolute value of this one. I don't need anything here. All right, it will cause a problem later, but we don't care. So let's go here. This is copy base. Oh, sorry. Let's copy this one and paste it here. Then I go again, copy, and I'll go all the way down. I don't need the positive data here, so I will only stop when I got to 0. Here is the positive data. We don't need all of these, so it is here, and click paste. All right, and now this is the values I would like actually to plot now. So let's copy the things here, and now this is the actual things we are going to plot. What I love to go is to go here and copy all these data points. This is simple Excel techniques, whatever you would like to do. Copy all of them, and then go to a new sheet and come here and say paste values. So I'm pasting all the values. Then what you do now, I will collect all of these data points and arrange them. So I will go sort, and when I open here, sort by VEB from smallest to largest, press OK. Now the data is arranged, so collect them and go here, insert chart. I will usually use this one, and voila, this is what we have now. Okay, then you go here, add axis title, click here and do the axis titles. So we know this is actually the IC in amps. Okay, and this value, this is actually VEB. You can write it VEB, and it is in volts. It's corrected. Okay, and here I prefer to give a short title. So the title for this chart will be the actual problem here, which is, it is PNP transistor. So let's write, this is what? This is VC, this is the IC, this is what we call it the input characteristics. I don't like to write this, I will write IC versus VEB, and this is basically for this type of transistor, which is PNP. All right, you want to write the number, it's okay. So this is actually PNP, and that's it. That's it. You can actually copy this thing. So let's see if I can actually lower this in the fonts and go here, make it subscript, sorry. All right, and I can do this with everything to make it neat. That's the only thing. I love making things neat. So this is here, here, and here. This is the font thing, subscript. So I right click and then choose this one, and this is your characteristics for this part. If you would like to play with the points, you can, but it's okay, it's good right now. And this is ending this first part of this experiment. Okay, now let's do the second measurement of part 2 in this lab, which is lab 7. So basically it is the same circuit, everything is the same. I don't want to do much changes in the connection, but I only want to change one or two things here. So let's be clear what's happening. In the previous circuit, we were changing V1 from -5 to 0. Okay, so, and this is actually the voltage that's connected to the base. This time I'm not going to change this voltage. I want this voltage to be constant and -2. At the same time, I will change V2 from -5 to 0. So the easy thing to do, or the easiest thing you can do here, is just to switch these two wires. Alright, let's look again. The W1 is a yellow with the function generator. So all what I will do is to remove the function generator and connect it to the other side. So all what I will do is to replace the white with the yellow. This is the white, I will take it out, not to lose the place, and then take the yellow out. Connect the yellow here at the same point, which is the collector now, and connect the wire, the white wire, which is a constant at 44 line again, like this. Now I switch the actual things, the actual power supplies. What about the measurements? In this part, I'm still measuring IC. Remember IC? IC was basically measuring the voltage across the collector resistance and divide the value by the value of the resistance, which is 250 ohm in the mathematics, which we'll do later, as we did, we'll do in the actual program. So the blue channel, which is channel 2 in this oscilloscope, I don't want to do anything with it. It will remain the same. While channel 1 need now to measure VEC. Previously I was measuring the VB, the VB's emitter. So right now I'm measuring VEC. So all what I will do is to remove the probe I have at the back here in the base, which is this orange one, and put it in the collector. So now I'm measuring the potential difference between the collector and the emitter. That's a very simple step, just to move it one step here. And that's it. Now the circuit is ready, and let's move to the waveform and do the rest of the analysis. Okay, now we are doing the second part of the measurement number 2. So basically what we need to do, as you just saw in the circuit, we are switching the two power supplies. So now I'm ramping the VCC while the V1 is at -2, not -5. So this is the first thing I would like to go here and change this one to -2 volts. Okay, so this is The function generator will be the same. All what I need is the values from -5 to 0. I don't need the rest of the positive values, which we eliminate later in the analysis. But this is everything. And I switch also the measurement, so now I measure VEC instead of measuring the VBE like last time. So let's run the function generator, run the power supply, and let's go to the scope. We're still showing the data. We still have the same mathematics is the same because this is exactly similar to what we have last time. We have this setting for the sampling rate for 256 samples and the 5 hertz, and we see that it's ramping, which is almost okay. We're measuring in the correct manner. So let's run the signal, and this is our data. So I will export the data file. Again, all this file here, everything is correct, seems nice. So let's go ahead and save this file, and data saved. Now let's go ahead and open this file. Here is our data. The files are here. Okay, I can just go ahead and do fast plot to see what it looks like. It looks like it's okay for me. This is fine. So we do the same thing as we did last time. Okay, so anything here we don't need. Okay, so let's first do small calculation here, and I will say this is let's do this similar. This is equal absolute value of this column. All right, and copy it again and put it here, and then copy both of them, copy, and we take it all the way to the negative parts only. It needs the positive. This is not needed because this is ramping from -5. Okay, all of the positive data here I don't need, so let's paste it. Okay, then I will call this VEC, VEC, while this one is IC, and I will copy them to a new sheet so I can arrange them in order. It's very simple. It's the same technique we do all the way around, just data analysis. Okay, copy, and you go to a new sheet here, and you can select the whole thing, but when you paste, you have to paste values. Don't go regular paste, it will give you error. So do paste values. And now I can go here and select the whole thing from here. You don't need to select the column at the top, the header. And we go to data, and we say sort. And when I sort, I will sort by VEC from smallest to largest, and here is the data. Then we just plot the value, insert, and then go here, chart, and this is my curve. Double click here to add the axis title and everything as we did last time. So let's do it fast this time. This is still IC in amps. All right, and let's do it directly at the same time. So this is what I do. Go font and make it subscript so it looks better. And this one is VEC. This is what we want to have it. It's VEC as the actual. Oh, I forgot the unit. Don't forget the unit. It's involved. And let's highlight here and go font, subscript, and at the top it's already ready. Okay, so I can actually go ahead and say VC IC versus VEC, and this is for PNB transistor. So this is the measurement, and let's neat it a little bit. Same thing here, and it looks nice, fine, very good. Now we are going to do the third measurement, which is the resistive DC biasing for both MPN and PNB transistors. This is the circuit is drawing already in front of us, so we start by the N-type transistor and PN transistor, and we follow the same procedure as we did last time. I will start the same, we don't have to repeat anything. So basically the transistor is here from left to right, again the same thing, and I will go again with the same method I did last time. So basically I will put it in the 3 legs here. So one in this one. So right now I have the emitter connected to line 35, while the base is connected to 34 and the collector connected to line 33. Okay, this circuit, for this circuit, the values we calculated from the previous part are 1.5 kilo ohm for RC, RE is 1 kilo ohm, RB1 or R base 1 is 3.3 kilo ohm, and R base 2 is 1.7 kilo ohm. These are the values we calculated. The values I have here, since I don't have all the values, I have actually 1.68, I have 3.33 and 1.5, which is 510. So I will have to connect a couple of resistance here in series to see what will happen. Okay, I will start first by the collector. So the collector is 1 kilo ohm and 500 kilo ohm. So this is the 1 kilo ohm and this will be the 500 kilo ohm. So let's connect it directly before we forget where they should go. They are in series also. So this is the collector. I will go from this terminal to a point here and then connect the second one, which will be the 500. So the sum of both of them will be the value we need. So this is going to the same terminal here, and then I will go to number 15 here to have a wide range so I can have the resistors look so good. Okay, so right now I have the RC connected very well. Our emitter is very easy, it's just 1 kilo ohm. So let's connect the emitter resistor this time, it's much easier. And here, this is 1. So now we have the emitter resistor connected. The emitter should be connected to negative VEE in the circuit, but since it's a ground already, so I will just connect it to the ground. So I will get another small wire as we did last time here, and it takes the last leg here which connected this one, and I will take it to a line here to consider it as the ground for this circuit. So now I have the ground, which is the line, the blue line at the top, which will be the ground for the whole circuit now. Let's look at the base. The base has 2 resistance actually, one going to the base, which actually is the resistor from both of them were coming from the base, but one going to the voltage supply for the collector, and the second one will be going to the emitter. So let's do with the first one first, which is the RP1. RB1 is 3.3 kilo ohm, so I will use 3 kilo combined with 330 ohm. So the value will be 3.33 kilo ohm. Again, this is coming from the base. Alright, so here it is. I'm just hoping that it's not getting crowded now. So here, this is the base one, and I will be connected to any point here, but we don't need it to be connected to the same point as the previous one. So let's be careful about this. So I skipped one point here, and just I make sure this is actually connected to this point. Then I will take the second resistor from this point to another faraway point here. Alright, so now we have another small thing. We need to have a positive input. So what I will do is I will take another short wire. Alright, and I will take the collector output here, and I will connect it to this positive line at the top. So this one tells me that the red here is the collector battery. This is where I will connect the VCC. So this is the same point I need this line to be connected to. So I will need another wire to connect here, and this will connect this terminal of the base to this point. So let's get another wire. These tiny wires are so helpful. So all what I have to do is to put the wire here and connect it in the top. So as we see now, this is RB1. So this is RB1 coming from the base and connected 2 resistors to have a sum of 3.333 kilo ohm, and both of them at the end they are connected to the same power supply. So this line will go up here to the same power supply where I put here VCC. Okay, we still have the second resistor, R base 2, So R base 2 is connected to the ground, so I will take it to the other side. This will be much easier for me. Again, I need 1 kilo ohm. This is the 1 kilo ohm. So 1 kilo ohm will come from here and connect it to anywhere here. But again, you have to make sure that you are not connected parallel with the previous resistor in any terminal. So this is the RP. Then I have another one from here which is 6.8. So we said the value will be a little bit off than the original value, and this should go to the ground also. So this one actually I can connect it to the parallel line. So maybe I can open the top resistor a little bit here, maybe more, give me some space here. Alright, and now I can actually connect this resistor from here to here. So both of them actually are connected to the ground, and now I will take this one and connect it here. So this is now the ground of the circuit. So as we see now, let's have a look again at the circuit. Transistor, the emitter of the transistor going through a 1 kilo ohm, and 1 kilo ohm going back to the ground, which is 0 here. Then we have the collector, which has 1.5 kilo ohm, 1 kilo ohm, and 0.5 kilo ohm, and this is connected to the battery, VCC. The base has two different resistors, both of them connected to the base. This is a point here in the middle. Let's lose a little bit. You don't need to have anything loose. So this is the base. One of them going this way, which is RB1. It is 3 kilo ohm and 0.3 kilo ohm, so 3.3 kilo ohm, and it's connected to the power supply. The second one is the base 2 coming from the base going this way, and it's connected to another one to make 1.68, and both of them connected to the ground of the circuit. So now everything is ready. What we are going to do in this part? In this part, we only need to measure values. So basically, let's find first the ground. So I will use the same device, the analog discovery. So where is the ground? The ground was the black one. So let's have a black line. This is my ground, and the black is connected to the ground of the circuit, which is this point. So this is the ground of the circuit, connected to the emitter and connected to the second base. Then we have a power source, which is only VCC, so it's only single value source. So for this one, I will take the V positive, and the V positive here was the red color, and this is the one we are going to use, and we connect this one to where is the power source will be, which is here. So this line now is the power source. Then the rest will be only measurement. So for the measurement, we are going to use channel 1 and channel 2 from the scope. We can use them as a voltmeter, or we use them whatever we want. So to measure IC, IC is the current running through the collector resistance. So let's use the blue channel to measure IC. So again, I will do the same thing. Here is the blue one. Where is the collector resistance? It's all this one. So I will go here at the end. Okay, and we need another blue from the negative of this channel to measure the current. So I go here in the collector. So this one now is measuring the potential difference across RC, and I can use the calculation in the scope again to measure the current. At the same time, I can just use a voltmeter if you want, or the oscilloscope, whatever works, from channel 1. So I will go grab channel 1, and I need to measure VC. So VC is a voltage at the C, so let's use this as a voltmeter. Where is the collector again? It is the same point we connect to it here. It will be hard to connect across all of this. It's complicated a little bit. So just to try to get it without touching anything here. So now I'm connecting to VC. This is measuring VC. If you would like to measure the voltage across the emitter resistance, I will do the same thing as the collector. All what I have to do is to take the two blue terminals, connect them across the terminal of the resistor, and I can use the voltmeter for this measurement. V2 is again the voltage across R base 2, which is the base going to the left, so I will use the same technique, and we will repeat all of this on the actual software when we do it. So basically, if you want to measure voltage across any resistor, just to move the two blue lines and put it across these two resistors. So again, VRE is the voltage across the emitter resistance. So that means you need to take this blue one out, and go ahead and connect them across the emitter resistance. Where is the emitter resistor? It is the whole thing, which is 1.5. So I can go to any line here. From here, this is the ground or 0, or I can go from the ground at the top and the emitter. This is VRE. This is actually the measurement of the voltage, and it will be 1. So use the voltmeter for this measurement. Then for V2, I will do the same thing. Keep this terminal as the same and connect this one to the base. That's it. Now we are doing the third measurement in Lab 7. The third measurement, we have the circuit already built in, so we already built the circuit. We have now transistor 2N3904, and the main idea is that we actually would like to measure the current IC. We just need values, so we don't need the oscilloscope this time, but we can use the voltmeter or the scope, whatever you want, and we need to measure the voltage across different values, so we need to move the wires a little bit. So again, if you would like to measure the voltage across any resistor, just use 2 terminals. I will determine only the blue for this case, and I will move it to measure the voltage. You need current, you need the voltage across terminal, and divided by the value of the resistor. I will start by the supply, all right? And it looks like that we are using the +1, and the +1 is connected to 5 volt. So this is basically 5 volt. And I will start running the voltage here. Now I go to, instead of supply, I go to voltmeter. Okay, so this is the voltmeter. So currently my connection will allow me to measure the voltage across the resistor. The channel 2 is connected to measure the voltage across the emitter resistor, which VRE. Okay, and the second channel, which is the channel number 1, is connected to measure VC. So let's run this and see what will happen. Okay, I only need one single run. That's all what we need. And now again, channel 1 measure the voltage at the collector VC. So this is thing here says that the VC measured to be 3.813, and this is channel 2 measuring VRE, and the value is 1.358 volts. Now I will go ahead, I stop the power supply for safety only, and I will measure IC. IC is the current in the collector resistance. So I will use the blue one, which is channel 2, to measure the voltage. Then I divide this voltage by the value of the resistance later. So, alright, so I will use channel 1 actually to measure the current. So it is already connected one, and I connected the other terminal to the base. So now I'm measuring from the collector to the end. So I'm connecting channel 1 across RC now. Now we still have one more measurement to do, which is the voltage R2, and this is across the R base 2, and this is the second terminal of the blue channel to the ground or the other base here. So we are measuring across R base. Okay, so now I will run it again, single run, and these are the values. It's measured now. These are very small values, so let's make sure. Oh, sorry, the power supply is not working. See, this is one mistake you can do. Run the power supply. Now the power supply is working, and do one measurement, and these are the values. Okay, so again, channel 1 measures the voltage across RC, and now I can say that VRC, this is what I would call it, VRC, ignore the negative because this is how the channel is connected. This is 1.426 volt. This value will need to be divided by RC, and RC in this case is 1.5 kilo ohm, and this will give me IC. The second channel, which is channel 2, the blue one, is measuring right now the voltage across the base resistor 2. So VRB2 is actually the voltage we have here, 1.541 volt. And this is actually good because it needs to be 0.7 plus the voltage across RE, so it's almost correct. Now we are going to do the second part of number 3, which is using the PNP transistor. This is the previous circuit, so what I should do here, if we look at the diagram, everything is the same. All what happened that we only use different transistor and we flip the polarity. So the collector is connected now to the ground with R base 1, while the emitter is connected to the power supply. So all what I will do, I will take the transistor out, and this is a 304. Let's put it back in its place. Then I will bring the transistor we used last time, PNP transistor, and we connect it in the same place, same way. Here, nothing changed here, right? Everything is the same. No, we still have one more thing to change. The two power supply, the ground need to be here, so the ground now is connected to where our base 1 is. And the values are the same as the previous problem. So all what I will do is to take this one and switch it with this one. So the ground is this side now. That's it. Now you want to measure, we'll do the same thing as the previous one. The measurement across using the two terminals of the resistor across every resistor. This is what we are going to do. Alright, so let's move now to the wave generator things and do the measurement and see what will happen to the values we are going to collect. For this part, we are going to do the actual measurement now for number 3, but now we are using the PNP transistor. The circuit is the same as we saw, so let's see what we're going to measure. Again, I have everything here is the same. So the voltmeter power supply is the same. Run the voltmeter, run the power supply, sorry. And let's go ahead and look at the voltmeter. I will connect the blue circuit across the emitter resistor to measure the voltage across RE, and I will use the orange one to connect and measure the voltage across V2. So V2 is from the base, so one term from the base, and the other one with the emitter as the previous one. And let's go ahead and do a single run. These are the measurements. So for PNP, now we are measuring VRE using channel 2, and the channel 2 give me 986 millivolt with a negative sign, while the V2, the voltage across our base 2 is 1.565 volts. And now we want to measure the current in IC. I will use the channel 2, which is the blue. I prefer to use it always for the current. I will connect it at the collector, so I will measure from the collector to the collector itself across the collector resistor. So now I measure the voltage across RC, and then we need to measure VC itself, and we can actually do this easy by taking the terminal and connect it to the collector itself as we did last time. So channel 1 will measure VC, while channel 2 is measuring the voltage across the collector resistor. And here a single run, and here are the values. So again, channel 1 is the orange one measuring VC, and this is VC is 1.438 volts, and channel 2 is measuring the voltage across RC, which is now negative 1.433 volt. I will divide this by 1.5 kilo ohm to give me the value, and this will give me the full measurements we need here. Now let's move to the last measurement, which is number 4 on this lab. So basically, this is a little bit complicated circuit because it's not only one circuit, it's actually two circuits connected together. This what we have. I have all the values here, but I don't have 750 or 740. So instead of 750 and 740 ohm, I will have to use the 680 ohm. Alright, so let's start. For this circuit, we need two transistors because now we are going to connect this one here. Right, I will zoom in a little bit so you can see what I'm doing. So here is one transistor, and I will grab another one. So be ready with this transistor here. Okay, I will start slowly building the first circuit, then I will move to the second circuit. So the good thing here is that everyone will have only one resistor. I don't have to do any series connection for this part. So this is my first transistor. This is the main transistor. The second circuit is representing a current source, and I will show you how to do it. So this will go here again in the same spot as previous, as we did before. And let's go ahead and connect 680 ohm. This is what I have. So this will be the collector resistance. It will go from here to a collector point, let's say here. And then I need one for our base one will be connected to the same spot. So it's parallel to this point. So our base one basically will be connected from the base here and end up at the same point. I don't have actually to do multiple points here. In this circuit, I will prefer to have actually a positive line of sight. So this will be our positive for the VCC. So this is now whole thing connected together. These two resistors are parallel but they don't have to touch like this. So it's moving here to VCC. This is the top part, and in the lower part I need R base. So let's find another resistor of 680, and this will be from the base till the ground or the emitter. So let's see how we connect this one. It is so simple. I will go here from this dot to anyone here to this side, which will be the emitter or the ground of the emitter. And to just remind myself, this line will be the ground for the circuit, so I will bring it here and connect it up here with a small short wire. So this is now the base, which is the lower point here, and it's connected to VE, which is 0. So that's why I put it ground. Now we need to connect the other stuff to the emitter. So basically it looks like complicated. It is not complicated, but I can actually move the circuit to the lower part. So what I will do, I will get a shorter wire like this orange, and I will extend the emitter to this circuit here. So now this is still the emitter line for me, and I will grab the second transistor, and if you look at the circuit, the collector of this transistor is connected to the emitter of this one. So I have to flip the transistor this way. So instead of having the transistor as a flat surface facing me, I will rotate it this way. Alright, and connect the collector here and the emitter here. So ignore the first circuit. Now this is the collector. The middle point here is the base, and the last point here is our emitter. If you look at the circuit, the emitter will be connected to a ground, and it's connected to 1 kilo ohm resistor. Alright, so let's do it. This is 1 kilo ohm from the emitter here all the way to a point that will represent a ground for this circuit. And I can actually combine the two grounds by moving this circuit or this resistor a little bit forward here, and use another short wire, and this short wire will be connecting the ground of this circuit to the ground of this circuit. So this is now the ground of the previous circuit. I will just only connect the whole thing to the same ground, so it will be 0. Now I need two. Each one is 1 kilo. I have one already here to represent the base. So this will go from the base to the VCC, and the second one go from the base till the same ground here. So I will put this one first. This is the base, and I need another one from the base to the VCC, which I will connect it up there here to something like this point here. So this line now need to connect to the same power supply here, which is VCC. I can do it with a wire from here to here or from here to here, whatever you prefer. Both of them are correct. So okay, so now let's revise the circuit. What I have here, the first circuit, a transistor, emitter base collector from left to right, and I have RC connected here, which is 7.7. This is RC, the top one, connected from here to the collector. And as a base, I have one from the base to the same VCC, which is this one, 1 kilo ohm. And I have another 1.7, which is this one here, connected to the ground of the circuit, which will be this line. And then the emitter is connected to the whole circuit, which we call it the current source in this case. The current source consists of transistor, but flipped. So basically, the collector of the new transistor connected to this emitter. That's why I have to flip it. So now this is the emitter going to the collector. Again, collector base, emitter. So this is the last one. Here is the emitter. Emitter in this case connected to 1 kilo ohm. So I have to take a base here, 1 kilo ohm to the 0, which is the ground of the circuit. And then the base is having two resistors, one going to the collector VCC and the other one going to the ground again. Now all what I have to do is to connect this point to the power supply I will use from the analog discovery tool. And again I'm using the positive voltage, which is the red. So the red one will actually go here. So this now provides the power supply for both circuits through this whole line, which is line 27 in this case. In the top part 27 and the lower one is 20, I think 26. And then we need a ground. The ground is the black again, and as we defined in the circuit, the ground is this whole thing here in this one. So now what about the measurement? We are going to measure many things. We are going to measure the current in the collector resistor, which is the main collector resistor, RC1 if you want to call it. So this will be the first thing. To do this, I will use the same technique for the blue channel across RC and measure the voltage and divide by the value of the resistance. We measure VC. This is a simple thing with channel 2. I will connect it to the collector and measure the voltage at this this point. V2 actually is the voltage across R base 2. This is similar to the previous circuit, so there is no problem here. Vx is the voltage across the whole source. So basically I will connect it from the emitter. So let's see how we can do this. This is the important one. This is Vx. I will connect channel, let's say the blue channel, to the emitter of the first transistor. Where is the emitter? Here. And what is the second one? The ground. That's it. This will measure the voltage across the current source. This is Vx. The last measurement is Vy, which is the voltage across R2 in the current source. So I can use the same terminal actually, if I want, and go look where is the R2. It is a resistance connected from the base to the ground. So it is here. I can actually go next to it if I can. Here, and the ground, which will be this point. And we repeat the same thing for the last circuit, which we'll see how this will work. Okay, now we have the circuit ready. So basically what we are going to do here is to measure the values as we did in the previous circuit. Exactly. So the first thing I will measure VC. So I'm connecting channel 1 to VC. So this will give me the voltage in the collector of the first transistor. And I have channel 2 connected to measure the voltage across the resistance of the collector. Power supply is on, which is the same value, 5 volts, nothing changed. And I will do single run, and here is the values. So basically channel 1, we said channel 1 is measuring a VC. So this is VC is 3.235 volts. And the voltage across RC from channel 2 is 1.711 volt. Then we still have 3 more measurements to do.